equal to 1, 0, 0, 1, right? If you look at the index defined, the index defined there, you can see that QC equal to 1, 0, or 0, 1. So an R equal to 1. And AC is this. Okay? Any questions? Just simply define those matrices out, AC, BC, and R and Q, and sub into your Riccati equation. That's all you have to do. Very simple. The control gain will be FC equal to F1, F2 equal to minus R inverse BC transpose P. Now we have to solve P, and P is this Riccati equations. Okay, now I'm going to solve it by hand, so you can have feeling about these Riccati equations here. But of course, now we don't have to do that. P equal to P11, P12, and P12, P22, and because they have to be symmetrics. And this is only 2 by 2. So P12 equal to P12. And now Riccati equations. You sub into Riccati equation, you got 3 equations. Because you got 3 unknown. Then you got 3 equations. Right? 3 unknown. P11, P12, and P22. And then you put into Riccati equation, you got 3 unknown. Now you can solve these equations. That's 3 equations for 3 unknown, but this is nonlinear equation, unfortunately. And so it's not as easy as we can do by just matrix inverse. The control gain matrix is equal to the F equal to 0, 1, and because I equal to 1, all right, and BC is BC transpose is 0, 1 transpose, that means 0, 1 will become a row. And now P11, P12, P21, P1, P22. So FC is nothing but minus P12 and minus P22. So from this equation, we have to solve minus P12 and minus P22. That means we have to solve P12 and P22. Any questions? I'm just using the formulations, and I will upload the problem number 9 either today or tomorrow. And it's already there. I didn't upload it because I didn't teach you this one yet. So I will upload the problem number 9 very soon. And it's nothing but apply these kind of formulations, and you can do it. It's not difficult. All right. Now consider the tau equal to 1 and omega equal to 1. Then from the equations, we saw we can obtain the P11, P and P equal to, there's 4 different P you can have. That's 4 different P. Now which P is the right P? I'm going to give you some hint. Which P? Of course, you know that you know. Right? P has to be positive definite. Right? That's so by eyes, it's easy to look at that. The positive definite matrix, all the diagonal elements must be positive. Well, for any positive definite matrix, all diagonal elements must be positive. Okay. So from here, that one, because negative square root 3, that diagonal element is not positive. So that part. If you don't believe me, you can go to check. That one, no, diagonal elements are, all diagonal elements are negative. So that's, that one too, all negative. Diagonal, negative doesn't mean anything, but diagonal element has to be positive. So only one which is positive definite is that one. So if you want to check your P is positive definite or not, first of all you have to check the diagonal elements. If any diagonal element is negative, that matrix is out. Now if there's two matrices, all diagonal, then are positive, then you gotta check the eigenvalues. Because that eigenvalue must be positive too. Right? But here you don't have to check the eigenvalue at all, because it's easy to see. Now, why is this true? And you can go to Google search and then it will tell you. Alright, so now FC equal to minus P12 minus P22, that means that's minus 1 and minus square root 3. So that's the solution for tau equal to 1, omega equal to 1. Any questions? Still no questions. I'm about to finish the optimal control, that's it. Alright, that's the optimal control. Let me add one more sentence. Now, our optimal control assume that the steady state gain. What do we mean steady state gain? The cost index is half infinitive, then xt qt plus ut r u, then that dt. And this is 0 going to infinity. This is the simplest you can ever have in the optimal control. That's the simplest. And u, we have u equal to fcx. Alright. And this 0 to infinity. This, if we minimize that, this is we call steady state. Alright, because that's from 0 to infinity. But the optimal control is not just like that. Optimal control, you can have J equal to half 1 from 0 to, say, a finite TF. Alright, I want a finite time. It's not infinity. And I can do that too, if I want to do that. Alright. Now, if that's the case, then your Riccati equation will be different. Because if you look at this Riccati equation here, if I go back to look at this Riccati equation here, let's look at the Riccati equation here. Okay, go back here. Yeah. That's a Riccati equation here. Now there's a Riccati equation here, there's no P dot. See, there's no P dot. There's no differential term. P is equal to 0, this equal to 0. There's no, that means usually the Riccati equation may not get like this. For this, Riccati equation may not get this. P dot, all right, plus AC T P plus PAC minus P BC R inverse BC transpose P plus Q equal to 0. All right, so there's a called dot term here. There's a differential term here. So to solve this, but if you go into steady state means this gone, so that equal to 0. So that's what we have here. So the one we got here is the simplest and also the most practical way for the optimal control implementations. So that's what we usually got this. So that one here, and then more than that, there's some other cost index. So when you read the optimal control book, then you can see that there's a lot of different J. Some J will be even have the XTF, all right, then QF, XTF plus 0 to TF, then X transpose Q, X plus U transpose R, U, then DT. This is, we call terminal control. If we have this, then we call terminal control. That means at the time T equal to TF, then my state will be that state. I define my state here. So it's not steady state. Doesn't allow you time from 0 to infinity. This TF can be 10 seconds, can be 1 hour, can be 2 hours. If T going to infinity, then become this. And the Riccati equation for this is different from, of course, from this, from that, all differences. So that's why the optimal control book is that thick, because they discuss all different kind of the index. Now, the optimal control problem is this. Then I will ask you just a simple questions. Okay. Here. Why I use I equal to 1? Why I use QC 1001? Why? Anybody give me some answers about this? And as we know that Riccati equations, the solution of Riccati equation depend on Q